Let us say we are given an impedance of 90 minus j25 ohms. Now, as we know that in a single stub matching, the line which are used for the matching purposes, the main line and the stub, they both have the same characteristic impedance, 50 ohms. So, the parameter which are to be now calculated are the length of the transmission line L1 that gives the location where the stub is to be introduced on the main line, and the length of the stub Ls. So, these two quantities are unknown. The impedance of the transmission line is same as the characteristic impedance of the line, which is 50 ohms. So, as we proceed, first thing we do is we normalize this impedance with the characteristic impedance. So, you get ZL normalized, that is this 90 minus j25 divided by 50. So, this will be 1.8 minus j 0.5. Remember now that this is the impedance. The stub is connected in parallel with the main transmission line. So, as we have seen earlier, whenever we have a parallel connection, the dealing with the admittances is more appropriate. So, first our task would be to convert this impedance into admittance and then carry out the single stub matching in terms of admittances. So, now we proceed as follows. Firstly, we consider the Smith chart as the impedance Smith chart. Since the impedance to be matched is 1.8 minus j 0.5, considering the chart as the impedance Smith chart, I mark this point ZL bar, which is 1.8 minus j 0.5. So, this point here is the impedance to be matched. I draw a constant VSWR circle passing through this point. So, this circle is the constant VSWR circle. Now, since we want to do the further calculations in admittances, first we convert this impedance to admittance. And as we have seen earlier, if I take a diagonally opposite point of ZL bar on this constant VSWR circle, then I get the normalized admittance at that location. So, this point, diagonally opposite point Q, gives me a normalized admittance corresponding to this normalized impedance. Let us say that normalized load admittance is GL plus JBL. So, essentially our single stub matching starts from here. This is the admittance which is to be matched by using a single stub matching where stub is connected in parallel with the main line. As we have seen in the single stub matching, the first is I move by a distance such that the resistive part of this admittance becomes unity. That means the conductance G1 that get transformed to the unity at this location. So, this point here, if I see, it should become some 1 plus j b 1. So, by moving along the main transmission line, first we set the conductive part to unity. Whatever is the susceptance part, that you cancel out by placing a stub in parallel with the main transmission line. So, here first we move on this constant VSWR circle up to a point where this constant VSWR circle intersects G equal to 1 circle, constant conductance G equal to 1 circle. So, this location here, this point now, which is given as R, this point is R. The admittance corresponding to this point is 1 plus JB1. How do I get the length or the location of this point? I just draw the radius vectors passing through these 2 points. That is the length which is L1 on the main transmission line. So, again I can read off the values of the length which are marked on the Smith chart. So, this location corresponds to 0.032 lambda, this is 0.152 lambda. I can get a length L1 which is 0.152 minus 0.032 is equal to 0.12 lambda. So, the location of the stub is 0.12 lambda from the load. Second thing we have to find out is the length of the stub, and for which this JB1 susceptance has to be cancelled. So, the stub has to introduce a susceptance of minus JB1. As we do, we take the mirror image of this point on the constant VSWR circle, find a constant susceptance circle passing through this point, take the outermost point on this circle. So, this point here T represents pure susceptance of a value minus JB1. So, now if I want to have a susceptance seen here minus JB1, from that susceptance if I go away from the generator till I reach to the short circuit point, then that gives me the length of the stub. So, from here this is my susceptance which I want to add. I have to move now away from the generator, so I have to go in the anti-clockwise direction on this till I reach to the short circuit point. And since now this chart has become now the admittance chart, the point corresponding to the short circuit is the rightmost point. So, this is short circuit. So, I move on this in the anti-clockwise direction till I reach to the rightmost point on the Smith chart. So, again I can read the lengths. This point corresponds to 0.25 lambda, this is 0.402 lambda. So, the difference of these two, that gives me the length of the stub, and that is 0.402 minus 0.25 is equal to 0.152 lambda. So, now we have got the length of the stub, we have got the location of the stub. So, in a single stub matching, if the impedance is given first and if the line is connected in parallel with the stub, then the first step is to convert the impedance into admittance. Beyond that point, treat the chart as the admittance chart. Do the movement on the constant VSWR circle on the admittance chart. While calculating the length of the stub, remember, since the chart has become admittance chart, so the short circuit point is the rightmost point on the chart and the open circuit point is the leftmost point on the chart. So, move on the chart from the reactance value which you want to match up to the short circuit point, and you will get the length of the stub. So, these are some of the problems which can be solved very easily